This first problem is just a distribution problem. So let's start by distributing negative 6x cubed through the parentheses. We have negative 6 times 3 is negative 18, and x cubed times another x is x to the fourth. Negative 6 times positive 1 is a negative 6, and the x cubed doesn't have anything to multiply. That's already in standard form because the highest degree term comes first, so that one's done in terms of simplification. To classify it based on degree and number of terms, this is a quartic binomial. Quartic because it has a degree of 4, and binomial because there are 2 terms. To the right, we have a distribution problem again. Negative 4 times positive 5 is negative 20, and y squared times y to the fourth is y to the sixth. Negative 4 times negative 3 is positive 12. Y squared times y squared is y to the fourth. Negative 4 times positive 2 is negative 8, and the y squared doesn't have anything to multiply with. It's already in standard form, and there aren't any like terms to combine, so that's our simplified answer. This is a 6th degree trinomial. Next, we have two different distributions happening with two different sets of parentheses. So the 2x squared needs to distribute through the first set of parentheses. 2x squared times x cubed is 2x to the fifth. 2x squared times negative 3x is negative 6x cubed. 2x squared times 4 is positive 8x squared. Then we're going to take and distribute this negative 2x. So negative 2x times x to the fourth is negative 2x to the fifth. Negative 2x times x is negative 2x squared. Negative 2x times 1 is just negative 2x. Now we need to look for some like terms. We've got an x to the fifth here and one there. Notice they're exactly the same term but with opposite signs. So when we add them together, we get 0x to the fifth, so those are gone. Then the next highest power I see is a negative 6x cubed, and there don't seem to be any other x cubes. There's an 8x squared and a negative 2x squared, so those will combine. And the negative 2x is also on its own. So it looks like my standard form and simplified answer will be negative 6x cubed plus 6x squared minus 2x. This is a cubic trinomial, since its highest power is 3 and there are also 3 terms. Now we see one of our double distribution problems. So we're going to write out what needs to happen. First, the 6h is going to need to distribute through the 2h plus 3. Then the negative 7 is going to need to distribute through the 2h plus 3. So 6h times 2h is 12h squared. 6h times 3 is positive 18h. Negative 7 times 2h is negative 14h, and negative 7 times positive 3 is negative 21. The two terms in the middle are the like terms, so we have 12h squared plus 4h minus 21. This is a quadratic trinomial because its highest power is 2 and it has 3 terms. This is a second double distribution. We need to start by distributing 9a through the 7z minus 4, and then we'll need to distribute the negative 8 through the 7z minus 4. So we have 63az minus 36a. Then we distribute the negative 8, negative 56z plus 32. As we look at that, none of these terms are like terms. They each have different combinations of variables or just no variable. The highest degree term is the 63az since it has a degree of 2. It comes first. So this is a perfectly acceptable format in which to leave our answer. Our highest degree comes first, the other two are given in alphabetical order, and the lowest degree comes last. We would call this a quadratic polynomial in 4 terms. This next problem is just a simple distribution. We're distributing x through the parentheses. So we have 6x cubed minus 4x squared minus 2x. It's in standard form, and this is a cubic trinomial. There we go. This one is a double distribution. First, we need to distribute the second x squared through the 3x cubed minus 2x. Then we need to distribute the negative 1 through the 3x cubed minus 2x. So we have 21x to the 5th minus 14x to the 3rd minus 3x cubed plus 2x. The middle two terms are like terms, so combining those, we have 21x to the 5th minus 17x to the 3rd plus 2x. This is a quintic trinomial. Don't forget, when we see a square, this means take the polynomial and multiply it by itself. So now we can see we have a double distribution problem. We're going to distribute that first x to the second x plus 5, and then we're going to distribute the positive 5 to the second x plus 5, which gives us x squared plus 5x plus 5x plus 25. Combining our like terms in the middle, we have x squared plus 10x plus 25, which is a quadratic trinomial. All right, we have a couple more of these multiplying binomials by themselves. So first we write the problem out. Then we show the two distributions that need to be done. And then we do those two distributions. Combining our like terms in the middle, we have a quadratic trinomial. First, we have to multiply 5x cubed minus 2 by itself. And we see that again we have a double distribution. We're going to distribute 5x cubed through 5x cubed minus 2, and then we're going to distribute negative 2 through 5x cubed minus 2. This gives us 25x cubed minus 25x to the 6th minus 10x cubed minus 10x cubed plus 4. So 25x to the 6th minus 20x cubed plus 4 is our final answer in simplified form, and this is a 6th degree trinomial. Now we have two interesting problems here. First, we have an x, which we need to distribute through x minus 5, and then a positive 5, which we need to distribute through x minus 5. We get x squared minus 5x plus 5x minus 25. Our like terms in the middle actually cancel each other out. They're exactly the same thing, but with opposite signs. So we're left with x squared minus 25, which is a quadratic binomial. Then on the right, we have a very similar problem. We're going to take and distribute the y to the y minus 4, and then the positive 4 to the y minus 4. So y squared minus 4y plus 4y minus 16 again has like terms in the middle that are exactly the same but with opposite sides, and we get y squared minus 16, which again is a quadratic binomial. Now I just want to mention that there's actually a special name for this pattern. Notice how in both cases you have something squared minus something squared, right? Because 25 is one of our perfect squares, and so is 16. This is called a difference of squares. And this always crops up when you have a plus b times A minus B. In other words, the two binomials are exactly the same except for the fact that the middle sign is opposite. And that looks like the end of your note sheet.